Okay, I think we can start now. So, as you know that this is our lecture tutorial number 3 basically for week three's content. So here are 8 questions again in the tutorial and we'll be solving them one by one. And interesting part is that all of the questions this week are all mathematical problems, numerical mathematical problems. Most of the earlier questions we solved are in earlier tutorials were mostly based on conceptual questions and some mathematics, but this week it is mostly mathematicals because it is based on the balancing formula of mechanical objects. We have to use two things. One is force balance and the other is torque balance sometimes, depending on what problem we are given. So here are some example problems that we are going to solve. Let us start one by one, right? So at any point, if you have any doubt or query, you can unmute yourself and ask me that. And if not, you can also ask at the end of the tutorial, or we can continue as we go forward, right? And maybe in between, I can also ask you that what this thing will be. Then, if you know the answer, you can also prompt some of the answers that I ask you questions to, and you can also like continue your own solution with the solution I'll be doing for you in this tutorial. That way we can learn much faster and smoother. So let us read question number 1 first. So this is saying that first of all there is a general statement that this problem is to recall the definition of torque, right? When a force is applied to an object, not only the magnitude and direction but also the line of action of the force matters. So you know that for torques, the line of action of the force matters because there are situations when even if the net force in the system is zero, but the net torque may not be zero because the line of actions of the different forces are not along the same line. So the net torque does not the net torque value does not become zero, and as a result, the system is not maintained at a mechanical equilibrium because it can always rotate, right? So that is why to deal with such mechanical objects and some mechanical like free body diagram problems, you do not only need to consider the force balance conditions but also the torque balance conditions, and for that you will need the observation about the line of action of the force. That is what is first of all stated in this question. Now this figure shows a pole, which is this one. Now a force F is acting on the pole at the point A. So this pole, so it is like a flag pole, and there is a point which is marked as A, which is here, and the direction of F is shown by the arrow. So the direction of force, that is the F, is like applied on that point A, which is this point, along this red arrow direction. Now suppose we want the force F generates a torque of 2000 Newton times meter, because you know that torque is nothing but the dimension of force into dimension of distance. So that is why it is Newton into meter is the unit. So if that is the torque that is generated by this force F vector at this point A, which is now the concept about torque is that you always have to choose some reference point or some pivot point of that torque. In this case, the pivot point is mentioned in the question, that is O, that is this point, right? So this is your pivot point and this is your application of force point, which is A. Now with reference to your pivot point O, there is a torque that will be acting because of this action of the force F vector, right? Now the question is that what is the magnitude of F in Newton if your torque value is 2000 Newton meter? Right, and there are some distance values given, like this distance to this distance is 2 meter and here to here is 4 meter, and this angle is 40 degree. Now let us choose a fresh page and look at this problem by ourselves, and for these kind of problems always make sure that you draw a free body diagram of that problem, because other than that you cannot grasp the concept of how to solve any kind of question that is given to you. It is very important that you draw the free body diagram, and also in exams there will be partial marking for drawing the free body diagram of such Newtonian mechanics problems, because half of your understanding depends on whether you can draw the diagram properly or not, right? So first of all, we'll start with drawing the diagram and then we'll balance whatever. So in this case, I think force, you do not need to balance much. You can directly use the formula. So I'll show you how to do that. First of all, let me go down and choose a page. So here we start our solution to those problems, right? Right. So our problem number 1 was that. So let me draw the pole here, right? So let's say for me, I'm not drawing it accurately. Also, so the lines may not be very straight, as you know that I am not accustomed of drawing on a soft copy like this on a paint tablet, but I think you can understand the concept. So in this case, this is your point O here, pivot point, and this is your point A here, which is your basically application of force point. And let's say we define this point as point B. Now, one second. Alright, so we have just started to solve this assignment for week 3. We are just in problem number 1. We have just got started. So you can continue from here. So I have just started to draw the free body diagram for this problem that is given to us in question number 1. So I am here trying to draw this pole that they have drawn in the question, where this pivot point is O here, and this another point A was given in the question, that is here. But I have, for our convenience, chosen another point here, that I have marked as B. So I have chosen this because I want to mark this length, which is given in the question as 4 meter, and this length in the question is given as, sorry, I think the lines are a bit uneven, but this is actually a straight line, you can see. This is 2 meter, and there is a direction of force, or the direction in which the force is getting applied, which is F vector, as mentioned in the question, is somewhat like angle like this, and this angle they have also mentioned as 40 degree, right? So what information we have from this question is that, first of all, very important for this force torque problems, is that what is your pivot point for the torque. Pivot point means reference point about which you actually calculate how much is your torque. Okay, so in this case the pivot point is O. Most of the cases we choose our pivot point to be our origin, that is 0, 0 point, for the convenience of the solution of the problem. And application point of the force F vector is where this is point A, right? Right. So our distances that is mentioned in the problem is OB, this length is, vertical length is 4 meter, and this horizontal length OA is 2 meter, right? Now you know that because this I have chosen as our origin, right? So any length or any distance you will be drawing will be with respect to this origin, will be measured with respect to this origin. Now for doing that, what I do first is basically I connect this line to this line. So O to A I connect, and I name this as our R vector. I hope you can see this color. It's a bit dull of a color, so I'll change the color. So this is, let's say, our R vector, which is marked by this line to this line, join this point O and A joined by this vector line, R vector. So what is R vector? R vector is the position vector of the application of force point A with respect to origin, which is also our pivot point, that is O. So in other terms, you can also say R vector is nothing but your OA vector, right? Now So because you can clearly see that this problem is a bit simpler problem because this is just in 2D. Because the things that is mentioned to you till now is in 2D, because this you can consider as your x direction and this direction you can consider as your vertical or y axis, right? So till now all these things are on the same plane, that is the xy plane, right? And now you have to just identify the vectors now for calculating your torque, because in the question it was mentioned that the torque value is 2000 Newton into meter for this application of force F. Then what is the force value F? So you have the torque information. Now you know what is the formula for torque for such cases. So we see torque vector we mark or identify as tau vector. So what is the formula of tau vector? Can anybody, any one of you can tell me from the lectures? I am sure you have seen that. So what is the formula of torque? Can anyone tell me? What is tau vector? Just unmute yourself and try to answer. I am sure you can do this. This is just a formal thing. Okay, anybody, can you, do you know the answer? You can unmute and you can just let me know. That way you can also participate in the solution, right? Okay, seems like nobody is answering, so maybe I will proceed on my own. So tau vector is nothing but your r vector cross f vector, right? So this is your torque vector definition. Torque is basically your r vector is basically the position vector of the point of application, which is in this case A, with respect to your origin, which is pivot point O. So connecting these 2 points is basically defining your position vector or r vector, right? And this f vector is nothing but your force vector. Now because these are in vector expressions, so there is some magnitude and some direction, right? So if you have to write down what is your r vector in x cap and y cap direction, how to define your r vector. So we'll see that if you draw a dotted line and connect these, you will see that this part up to here is your r vector's x component, which is your distance same as 2, right? So this is basically 2 along x direction, so this is 2x cap, right? And this direction, which is the vertical distance of r vector component, is basically nothing but this distance OB, which is 4. So this is 4y cap. You can see both are for positive x and positive y directions, right? So for r vector, which is defined like this, from O to A point, it is nothing but, if this is your origin 0, 0, then this is your 2 meter and this is your 4 meter and this is your positive x axis and this is your positive y axis. So then r vector, you know from the vector identities, as you have learned earlier, that r vector can be written down as 2x cap plus 4y cap, that is dividing into components along x and y. Okay, so this is also called the moment, I think moment arm or something this is called as. Okay, moment arm is basically what is the distance of the application of force point from the pivot point is called the momentum. So this is not momentum, so this is moment arm. So I think you are familiar with the term if you have seen the lecture. So this is r vector equal to 2x cap plus 4y cap. Now what is your f vector? So similarly, because f is a vector, so it also has x component, which is fx times x cap, which is the direction unit vector along x, and then it has a y component, which is fy y cap. Now similarly, you can now decompose this f into 2 components along x and y and write it down as fx and fy. So in your case, what will be fx and fy? First of all, you have now information about this angle 40 degree, right? So this direction along x will be containing your fx component, right, along x cap, and this direction, if you decompose this f vector into x and y, so this direction will be your y component, which will be your fy minus y cap. Why? Because this is in the negative y-axis. Sorry, I have drawn this wrongly. So this will be minus y. So this is positive y. So by convention, you know that x cap along positive is basically towards the right, and y cap vertically up is considered as a positive direction. So vertically downwards will be minus y cap, right? So similarly, if this is x cap, this will be minus x cap in the left direction. So for your components of if so if from this point you draw your f vector, so it has two components, fx, and the other component will be along this direction, which is fy. And this angle is known to you. This is theta is equal to 40 degree. So by sine cosine rule, you know that the x component fx is nothing but f cos theta. Similarly, fy equal to f sine theta. Now you can see that fx is along the positive x direction. So this is plus x cap. And fy is in the negative y direction. So it is minus y cap. So we write down the magnitudes that of fx and fy. Fx, it is f times. So f is basically the magnitude of f here. F cos 40 degree positive x cap. Now it is y is along negative y cap. So we first put the negative sign, and then again it is f's magnitude f mod. Then it is sine theta, which is sine 40 degree into negative directional y cap, right? So this is your f vector defined like this. Now our problem becomes pretty much simple to define or to identify, determine your torque vector, which is r cross f. So you know how to do vector cross products. You have to write it down as x cap, y cap, z cap. Now r vector has, I think it was 2 along x cap and 4 along y cap. So this is plus 2 along x cap, plus 4 along y cap, and there is no z cap component, so it is 0. For f vector, it has mod f cos 40 degree along x cap minus mod f sine 40 degree along y cap, and there is no z cap component, so z cap is 0. So once you do this, you will see that for x cap, this component will become 0. For y cap also, you will see that you have no non-zero component, so it is also 0. And only for z cap, we will see there is a finite non-zero contribution. So this is z cap. For z cap, the component will be minus 2 f vector sine 40 degree minus 4 f vector mod cos 40 degree, right? So this is minus 2 you can take as common, and also modulus or magnitude of f you can take as common. So this is sine 40 degree plus 2 cos 40 degree, and this is z cap for the direction. Now if you forget about the direction for the moment, because in the question it is only given that the magnitude of this torque is 2000 Newton meter. So the magnitude will be, in the modulus value the sign will be gone. So the magnitude will only have plus 2 f mod sine 40 degree plus 2 cos 40 degree equal to 2000. So mod f. So here at this point you have to calculate, or you have to use your calculator and get what is your sine 40 degree and cos 40 degree. So it's like I am using my calculator, and sine 40 degree is coming somewhat approximately you can take as 0.643, up to 3 digit it is approximated, and then cos 40 degree will be 0.766. So this is 2 times 0.766 equal to, this is 2 and 2000, it cancels out to make it 1000. So what will be your direction magnitude of f? It will be like 1000 divided by 0.643 plus 2 times 0.766, right? So this will be your, now use your calculator. So 1000 divided by 0.643 plus 2 into 0.766 if you calculate this, you will get, just use your calculator like I am using. So I am getting a value of 459.77. So this is 459.77. So this will be in Newton units. Okay. So this is the magnitude of the force. This was asked in your question, right? So the question that was asked was, what is the magnitude of the force in Newton? So that we have calculated perfectly. That is, our answer is 459.77 Newton. In the option key, answer key, they have given the range of answer is 458 to 461, which is falling. Our answer is falling within this range. So this is basically depending on how much decimal points you are taking or approximated into. That based on that, there is a range given, but our answer is perfectly within this correct range. So our answer is actually what it should be from this question. Now there can be multiple ways to solve this kind of problems for torque and forces. Like the way I have shown you is directly using the formula R cross F, right? But there can even be some processes where I think it is mentioned in the lecture already that you can also, instead of just directly taking the cross product, somewhat there you have to calculate the cross product, but you can also deal with just component wise values, and then you can get your direction of that force torque vector by your cross product rule, directional rule, that is your right hand rule, somewhat like that. How to do that is basically like say you have your tau equal to, so this is your process number 2 that you can also follow. I think some of you are also comfortable to follow this process, and some of you will be comfortable to follow process 1. So based on your choice, but I'm showing you an alternative way also, where this tau vector is again the formula remains same, R cross F, but since this problem asks about the magnitude, so here also you can directly take the magnitude, right? And you know that this value will be like R magnitude, F magnitude, and then sine theta, because this cross product involves a sine theta, where theta is the angle between R and F, right? So theta is the angle between R and F. So like in our case, so this was our pivot point O, this was our application point of force A, and this was our R vector, and this was our force vector. Okay, so while I am drawing this way, it is as if looking like these are two perpendicular, but they are not perpendicular actually. There is some angle in between them. Let us go back to the question and see. Yeah, so if this is your thing, R vector, so they are not perpendicular. There is some angle that is in the way. So this is your F vector. This is your 40 degree, right? And so this is your angle that is in the formula, that is theta. Okay, so or in other words, you can also extend this line of, let's say I'm using a different color. This is your, let's say, line of the position vector R vector. Now you can also extend this line up, right? So this is your R vector extended like this, and this is your F vector already there. So okay, so this was your R vector and this was your F vector. So the angle in between will be I think there is a problem. This time I made a mistake here. So you have to identify your angle. This is r vector, this is f vector. So this becomes your entire angle, right? But in this case, because you see that this is your f cos 40 degree and this is your f sine 40 degree, right? So from here you can also like work component by component. Like your along x-axis you have this f cos 40 degree is the force component, and the distance from the pivotal point, if you take this horizontal distance from O, only horizontal, not the vertical one, so that is just 2 meter, right? So here in this case r cross f will be along x direction will be r is 2 meter and multiplied by f x-axis component is f cos 40 degree, and because these and these are basically they are like along the same direction, so that is why just take their product is 2 into 1 second, just 1 second. Sorry, I have made a mistake because this is not a dot product, this is a cos product, you can see. Okay, yeah, so basically along x cap you have 2 meter and along y cap you have the distance as 4 meter. Now basically because your torque has r cross f, so there has to be if they are perpendicular to each other, if their angle is 90 degree, then sine 90 degree you can say that is 1. Okay, so based on that you know that for this cross product you have to choose components that are exactly perpendicular to each other, so that there is no extra angle in between. Like for this case, the horizontal shift along from pivotal point is 2 meter. So if your x you take as 2 along x cap, then your f has to be in the vertical direction, right? So that is your the magnitude of the force in the vertical direction is f sine 40 degree. So this is f sine 40 degree, and remember this is just about the magnitude. So when sine 90 degree equal to 1, so this is the magnitude. So there is no sign plus or minus sign, just the magnitude is given. And similarly for the other directional component, which is if you take the r to be along the y cap direction, the distance will be 4 meter. So 4, and the perpendicular to that the force component is your horizontal force component, which is your fx, right? So you can also say that this is your basically x times fy plus y times fx, right? This will be your magnitude of the torque. So x is 2 and fy is f sine 40 degree, again y is 4 and fx is f cos 40 degree, which is the whole magnitude. And if you compute that and compute the values of cos 40 degree and sine 40 degree, you will again get a value of you put the values and you get values of, I think cos 40 degree is how much? Cos, I just calculated that, but yeah, so cos 40 degree into 4 is there, so into 4, so this is 3.064 into f plus this is 2 times sine 40 degree, so 2 times sine 40 is equal to 1.285, 286 approximated into f. So this is the whole magnitude of the torque is equal to given as 2000. So you can also use this formula and get your f, and you will see that your f will come as the same value that we have obtained before, which is around 459.77 Newton. So this is matched. Now I prefer the process number 1 that I have shown you earlier, because there I have less lower possibility of confusing it, because sometimes there is cross product and you just forget and you just like start to multiply like a dot product. So that is why I avoid process number 2, but process number 2 is also fine if you are confident with that process study. So by this process, the only disadvantage is that you only get to see the magnitude of the vector quantity, which is the torque in this case. Like r cross f magnitude we have taken, but to actually determine the direction you have to again apply the right hand rule. And you see that by applying the right hand rule, if your r vector is along this direction and your f vector is along this direction, so this is your f vector and this is your r vector. So basically what you do is that you like put your right hand rule. I think you all know. So basically you put all your 4 fingers combined up along the direction of r, which is your starting vector, and then now depending on, because your f vector is downward direction, so you like coil your all 4 fingers in the downward direction. So if you do that, your thumb will be pointing towards the page, and it will be towards the page and perpendicular to the page, which is like, so I cannot show you that in 3D, but it is basically represented by this cross sign, because there is a vector which is towards the plane of the page and perpendicular to the page plane, pointing towards the page. So this is a cross direction, and this means that there is a minus z cap direction, which we had identified from the cross product, directly taking the cross product formula without only considering the magnitude. The advantage is that here you directly can get the sign and direction, everything alongside the magnitude. So this part takes care of the magnitude part, and this minus z cap is the direction of the torque vector or tau vector. So that is why I prefer process number 1, because you directly get to see your magnitude of the torque and the value or the and the direction of the torque and the magnitude of the torque. So that is basically the configuration, that if this is your first vector, this is your second vector, then the cross of 2 vectors is basically pointing towards the page and perpendicular to the plane of the page, which is in this case minus z cap, because this is your positive x cap, this is your positive y cap. So your z cap will be towards this direction. So this is z cap is here, but your x cap so let me draw it again. So this is your x cap, this is your y cap, so this is your positive z cap. So these are all positive directions, right? Positive axis directions. But because your r vector here it has both x and y components, right? So this is some x cap and y cap, and this f vector also has some x cap and y cap, but the direction that they are combining, their combined cross product is pointing into is this direction, which is perpendicular minus their direction. This is towards the plane of the page and perpendicular to the plane of the page. Okay, so our first problem is solved. Now we move on to the second problem, which is the again there is some torque problem is given, right? So the first 2 lines are the same, we do not read that. This is basically a gear problem where a gear mechanism is given. Okay, so there is a figure that shows a gear where this is the central point of the gear, which is O, and this is the circumference of that gear. And along the circumference there is a force F vector that has a magnitude of 40 Newton that is applied. That is applied at an angle theta to the circumference of the gear. So there is a force which is this red arrow, and from the circumference dotted line, which is this angle of that application of force is theta, and this is to the not to the circumference but to the vertical axis that is shown in this figure. So if this is your one point on the circumference of the gear, and if this is the vertical direction from here, so from the vertical axis towards the force vector, the direction the angle is basically theta. Then for what value of the moment of F about the pivot point O will be maximum? So you are asked that what is the value of the force F for which the moment of the force about O is maximum, or in other terms, for what will be the value of F for which your torque tau about the pivot point O will be maximum. So for tau maximum, what is your magnitude of the force. That is the problem given to you, right? So this we can solve here only. So this is your, there is a circular gear given and there is a pivotal point O. Now, so for this pivotal point, you know that what is the definition of torque? Torque is basically R vector cross F vector, right? So if this is basically a radial direction, right? R. So if this is your R, so then this also is your R, right? So then if this is your pivotal point, which is your origin 0, 0, then along this, on this circumference point, which is A, let's say this point is A. So along this is also your R vector, which is same as this radial distance 300 mm, which is like 0.3 meter. 0.3 meter is equal to 300 mm is equal to radial distance of the gear. Okay. Now along this line, if you draw a vertical axis, so and this is your horizontal line, so your force is applied like this. Your force is like this. This is the direction of the force. Okay, this is the arrow. So this is your force and this is your angle theta. Now you can see that your tau is r cross f. Now for what value of the angle, for what value of f the torque will be maximum? So I think they are wanting to ask in the question, there is some printing mistake in the question. So they are basically wanting to ask what is your angle theta value. So for what value of the theta? For what value of theta, the angle of the moment of F about pivot point O will be maximum. So this is your O and this is your A point. And you have to know what is theta is equal to what, not F, sorry. Theta equal to what for tau to be tau max. Right. So basically, this is your F. So if this is theta, then this will be a 90 minus theta, right? Again, if this is theta, this will also be your theta because this is also along the vertical. So this is your F direction and this is your R direction. So what is this angle? This angle is then 90 plus theta, this whole angle. Sorry if there is a coloring, I think I may use different color for you to identify easily. So this whole angle is 90 plus theta. Why? Because this smaller angle is theta and this larger angle is 90 degrees. So the whole thing becomes 90 plus theta. And this is the angle between R and F. So the angle between theta prime equal to 90 plus theta. Now torque magnitude is R F sine theta prime. Or theta prime is the angle between R and F. So here it is R F sine 90 plus theta. Now you know that sine 90 plus theta makes it sine 90, so it makes it cos. So cos theta, you forget about any other sign, just it is a cos theta. Now cos theta, RF is basically your tau magnitude. Now for tau is equal to tau maximum, it has to be maximum. Then you know that irrespective of the values of r and f, your cos theta has to be maximum. Then your cos theta has to be maximum. So for what theta cos theta is maximum? So you know that theta equal to 0 degree makes cos theta equal to cos 0 degree equal to 1, which is the maximum value of cos theta. So basically your angle value theta, if it becomes 0 degree, then your theta prime becomes 90 plus theta, which is 90 plus 0 is equal to 90 degree. So then your r f sin theta primes becomes r f sin 90 degree, which is, it becomes 1 in the second quantity. This is 1. So this is just mod of r mod of f. So because these are fixed values, so then the whole thing becomes maximum only depending on the choice of the angle. So if the angle theta is 0, which is making the overall effective angle between r and f as 90 degree, then your torque is max. So the answer is 0 degree, which is also the correct answer. Now question number 3 is that again we ignored the first line. So this is a simple model of lower arm of human hand holding a ball with weight W is shown in the figure. So there is an arm, human arm is drawn, and that arm is holding this green colored ball, right, which has a certain weight of W. Now the combined weight of the ball and the lower arm is supported by the tension T generated in the muscles of the upper arm. So because this ball has its own weight W, and this lower arm, which is from the elbow to this lower end, has a combined net weight from the center of mass, that's 23 Newton, right? And this whole weight of the ball and the lower arm is supported by the torque that is created in the muscle of the not torque, the tension, which is basically a force that is generated by the muscles of the upper arm. So which is this red line. Red line generates a tension which actually holds these two weights. And now it is mentioned that suppose the weight of the forearm is 23 Newton with the mass center at G. If the maximum value of P such that the upper arm can generate is 300 Newton, then what is the largest weight W in Newton it can support, so that the overall moment of the system about O will be 0. Note that the line of action of T does not and cannot pass through O. Okay, so it is mentioned that you have to calculate that what is the maximum, what is the largest weight W that this upper arm can support if the maximum value of T that this upper arm can generate is 300 Newton. Okay, and the net overall moment of the system about O, that is the overall torque, is 0. So this is the question that is given to you, right? So you have to basically here balance your torque, because this is a torque balancing kind of a problem, because it is already mentioned in this problem that you have to make the net moment of force for such a system to be 0. Basically your net torque will be 0. So you have to balance the overall torque such that the net torque becomes 0 for this question. And torque is basically R cross F, right? So keeping that in mind, we'll be trying to solve this problem. So let me just remember these. What are these values? So this is 33 centimeter from here to here. This is 15 centimeter, and then this is 5 centimeter, right? So what we'll do is we'll draw a free body diagram. So this is question number 3. So forget about the hand and everything, just draw the free body diagram. So this is your vertical line. This is the pivotal point with respect to which torques are applied. So with respect to O, this also may be considered as the origin. And this is the inclination like this, where basically the hand is moving. So this is your point A. And on from this point A, there is this weight of the ball acting, which is W. And there is also this center of mass point G, from which the lower arm overall weight 23 Newton is acting upon. And now this overall distance is 33 meter. Okay, and this distance from O to G is, sorry, this is not meter, this is centimeter. So this is 33 and this is 15 centimeter. And there, this on this point, there is application of a torque along the vertical direction. So this is your T, right? So this is your T. And this distance is given as 5 meter. Now we have to use the torque balance formula to make the overall net torque in the system will be 0. And how to do that? First of all, you have to identify what are the forces and what are the moment for those forces, and then you have to make those equal to one another so that the overall net torque becomes 0. Now, so this angle, I also forgot to mention that this angle is given in the question, and this angle is basically 55 degree, right? So now you know that tau is equal to R cross F. So now if you talk about, this is your x-axis direction and this is your y-axis direction. So if you just talk about the magnitude of the torque and equilibrate them to get the torque balance, that will also do your case. So basically in this case, the net downwards direction forces are this W weight of the ball and this 23 Newton weight for the lower arm. So we consider both of them separately, that this force is W in the downwards direction. So what will be acting as a R for this downward direction or y directional forces of these weights is basically a x-axis x component of the distance. Like for A on this point where the W weight is acting, so there OA is the horizontal distance from the pivotal point to A, which is like 0.33 meter is the distance along x cap from your pivotal point to A, where the weight W is applied downwards. So here W is nothing but the gravitational force. So you can balance out, you can get the torque for this case. Torque for this about the pivotal point axis O is equal to R cross F, which is irrespective of direction if you just consider the magnitude. So magnitude of the torque, if you can see, is just so mod of R mod of A sine theta in this case is basically, here your W is along y cap and your x is along this, so they are both perpendicular to each other. So basically your theta becomes 90 degree and this is sine theta equal to 1. So this is simply R F into 1, and in this case R is just 0.33 meter and F is your W, right? So this is 0.33 into W is the torque for this W weight. Similarly, about the center of mass of this lower arm, which is G, if you take the weight that is gravitational force or weight that is from the lower arm that is acting downwards, this is 23 Newton. Now we have to get or determine the distance from the pivotal point to G, which is the horizontal distance, so that they are perpendicular to each other again, and there is sine 90 degree, which is 1. So you have to get this distance. Now to get this distance, you have two information, which is like, consider this is as a triangle. This is your G point, this is your O point, and this is, let's say, your another point, which is, let's say, B. This is B, and this angle is known as 55 degree from the question, and this distance OG is given as 53 centimeter, which is 0.15 meter. Now we have to get what is this distance, what is VG. Okay, so for BG, because that is the perpendicular to the 23 Newton component here, so this is perpendicular to that. This is 90 degrees, so 90 degree sine 90 degree equal to 1. So what is this distance? So this distance, so BG for this triangle OBG, BG is your perpendicular directional component. So BG by this distance is OG, BG by OG is equal to sine 55 degree. Now BG is unknown, but OG is known to be 0.15 meter is equal to sine 55 degree. So BG is equal to sine of 55 degree, you can take your calculator, into 0.15 meter, which is like 0.123 meter distance. So magnitude of torque for 23 Newton from lower arm weight at G point with respect to the pivotal point O is equal to, again, R F, then their angle is sine 90 degree, so that is 1. So in this case R is BG, which is 0.123 meter, into F is 23 Newton, into sine 90 degree is 1. So this is 0.123 meter into 23 Newton, which is like 2.829 Newton, and this was also in Newton, where W was unknown to us. Now this is the whole like moment of force that is there from these two lower arm weight and the object or the ball's weight, which is W. Now the tension from the upper arm is T along this vertical axis. This is T, right? And with respect to the pivot O, the T is situated at a R distance of 5 meter along X axis. So this T and R, they are both perpendicular to each other. Again, so their torque will be like T into R magnitude and sine 90 degree. So torque from upper arm tension T is equal to mod of R, mod of T, and their angle is already sine 90 degree, which is 1. So in this case R is 5, I think 5 meter was given, or sorry, 5 mm. So again this is 0.05 meter into tension T. Okay, so tension T is the force of the upper arm, which is given as 300 Newton, into 1. Now for torque balance, under torque balance the overall torque in this body will be 0, so that there is no rotational motion of that body, which is the given condition of the question. So net torque has to be 0, so overall system has no rotational motion, and that is stable. So basically you equate your torque from the weight from lower arm and the ball with the torque from the tension of the upper arm. So this is your torque from the ball, which is weight of the ball, which is 0.33 into W. So 0.33 times W, plus the torque from the weight of the lower arm, which is 2.829 in Newton meter basically. So this is 2.829 is equal to the balancing torque from the upper arm tension, which is T, which is like 0.05 into 300 Newton meter. So this units we do not consider further but 0.33W is equal to 300 into 0.05, which is 15 minus 2.829, which is 12.171. So W becomes 36.88 Newton. So this is your weight of the ball. So let us go back to the question. What it was asked in the question is that, so the question was, what is the largest weight of the ball W so that the overall moment of system will be 0. So for net moment of force in the system or net torque to be 0, maximum W achieved is 36.88 Newton is our answer. Okay, so in this case it is within this range of answers given, which is 35 to 37 is our 36.8. So this is also the correct answer, right? Now question number 4, let us move on to that. It is saying that this problem is to remind you that torque is a vector. This is not so clear if the force and the moment term are in the same plane, but becomes obvious in 3 dimensions. Recall that the moment term refers to the position vector of the point of application of that thing I was mentioning about earlier. That moment term is a position vector of the point of application of the force from the pivot point. In figure, we have a mechanism called turnbuckle used to adjust tension in a cable. For example, in ships and ropes in a box or in a boxing ring. This turnbuckle is tightened until the tension in cable AB is 1.2 kilonewton. Calculate the magnitude of the moment in kilonewton meter about 0.0 of the tension force acting at point A. So the tension of that cable AB is mentioned. Now the torque in kilonewton into meter has to be determined. The torque's magnitude about 0.0, and the tension force is acting at point A. So basically, if you draw a free body diagram, this is your O, which is the pivot point. This is your A, which is the other end of that pole, and this is your turnbuckle's cable, which has some tension T, right? So this will have some tension T. So this is a 3D diagram, so I don't have to draw it like this, but let us start with drawing the diagram first. Okay. So this is your question number 4, right? So this is saying that this is your one axis, this is your pivot point, this is one direction, this is the other direction which is Y, this is one direction which is X, and this is the other end of that pole which is A, and from here, so this is in 3D, this is your Z cap direction, this is the X cap, this is the Y cap direction. Now there is a tension that is acting on this cable of this turnbuckle, which is tension T vector, okay, which is pulling it up, and this is ending at, sorry, I think there's a bit problem when I am drawing it with hand. Just I am trying to draw that this is a parallel line to Y, and this is actually getting joined here. Okay. So this is your x direction, this is your y direction, then this is your another root over x squared plus y squared in blue, and then this is your z direction. So this becomes your root over of x squared plus y squared whole squared plus z squared and whole root. Right, so this is your x squared plus y squared plus z squared. This is the magnitude of the 3D distance vector that I am talking about. So in the question it is given that this distance along this vertical direction is 2 meter. So this whole distance is 2 meter, and so let me draw it. And this direction is basically your 0.8 meter, whereas up to this direction is your 1.5 meter, right? So from here you can draw that if this is the y direction, this is the x direction. So this is, so I have drawn it wrongly. I think this is not x because x is along that direction. This is your y basically. So whole 1.5. So let me modify this. This is not okay. So now this whole distance is basically your whole distance up to this is 0.8 meter, and because this and this is these are same, and this whole distance and this whole distance is 1.5 meter. So these and these are also same. So if that is the case, then by Pythagoras theorem, you know that this distance will be root over of 0.8 square plus 1.5 whole square, right? Right. So then, if that is your case of defining this distance, then maybe we should look at the problem once. Yeah, I think in this 3D case it will be much clearer. So this is 1.5, and sorry, this distance is 0.8 and this distance is 1.5. So then by Pythagoras theorem, what is this distance? Sorry. By Pythagoras theorem, what is your this distance? So this is the distance is root over of 1.5 square plus 0.8 square. Now if this is this distance, then also you know that these are two diagonals basically of this rectangle. So this distance is also the same, right? So this blue one will also have the same length of 1.5 squared plus 0.8 square whole root. Now if this is this and this whole thing is 2, right? So now then what will be this buckle distance or length? This will be root over of 2 squared plus 1.5 square plus 0.8 square whole root whole square equal to root over of 2 squared plus 1.5 square plus 0.8 square, which is, if you calculate, it will be like 2.625 meter. So this is your direction or magnitude of from A to B, right? Now there is a tension that is acting on this turnbuckle exactly, which is along this direction. Tension is a force. So you have to know that what is your torque along with magnitude and directional information, right? So this is that along the this axis that torque will be acting. So tau equal to R cross F, right? There's some mistake in this problem. Okay, so above distance is also given as 1.6. So in this case, you T instead of F, you have to write this as T. So if your pivotal point is O, then your R vector will be with respect to pivotal point to the application of force point, which is this, right? So this is your OA. So your R vector is basically your OA vector, and your T vector is nothing but mod of T magnitude, and the direction is the direction of AB, right? Direction of AB vector. So you have to calculate what is the unit vector in the direction of AB. That you have to calculate. So if that is the case, then what is this vector direction if you have to calculate? So this point is B, this point is A. So what is the x, y, z directions with respect to that? So x direction, you know that this is the whole point 8, right? So AB vector is equal to 0.8 x cap plus the y direction is 1.5 y cap and the z direction is 2 z cap. Now in this case, because the force is applied on the torque is acting, the tension is acting by the turnbuckle on this direction. So this will be minus z cap. So yeah, so this will be minus z cap. So your unit vector for the application of the force or tension is T vector is equal to AB cap is equal to AB vector by mod of AB vector, which is like 0.8 x cap plus 1.5 y cap minus 2 z cap divided by root over of 0.8 squared plus 1.5 squared plus 2 squared. So this is the unit vector for the direction of the force or tension along the turnbuckle. So this is basically, if you calculate this, there will be a certain value. I am not writing that down. But then the force or the tension vector equal to T vector, which value it is mentioned in the question, that is 1.2 kilonewton into the direction of AB cap, which is the AB cap unit vector, is this 1.2 into 10 cube Newton, then 0.8 x cap plus 1.5 y cap minus 2 z cap divided by root over of this whole thing that we have calculated earlier, that is something as 2.625. This is your the force which is in Newton, right? Now it is mentioned that the torque has to be calculated, right? So the torque is basically, so now that we have the information about the force or the tension of the turnbuckle is equal to T vector, the vector information is such that it is 1.2, 0.8 x cap plus 1.5 y cap minus 2 z cap, because if this was your point A and this was your point B, so along this line the T vector is acting, right? Okay, and this is your pivotal point, which is O, and this is your OA vector. So the R vector equal to OA vector, and T vector is the same direction as AB vector. So once this is, the force is now got obtained by this divided by the magnitude 2.625, this is in kilonewton. So the torque will be cross product of the R vector and the tension vector. So torque tau vector is equal to OA vector cross tension vector T. So then what will be the cross product? Dividing into x cap, y cap and z cap component. So OA vector, if you see carefully, that OA vector is can be written as, so it has only x and z components and no y component, because this is your O, this is the origin point, right? And this up to this, that is along x, and this was along y, which is not, there is no displacement along y for this A case, A point, and there is only displacement along z. So there is x component and z component. This is sitting in the xz plane. So the OA vector can be written down as, because this distance was known, up to this was 1.6 meters. So this is 1.6 x cap plus here to here, this distance is given in the question as 2 meter. So plus 0, no component along y, plus 2 z cap, right? So then OA cap will be 1.6 for x, 0 for y, OA vector, and z is 2. Then similarly for T vector, you have x, y and z component. So this is, you put down the values, that this is, you take the common thing out, which is 12 by 2.625, and the rest of the components are 0.8 along x, 1.5 along y and minus 2 along z. So this is in kilonewton times meter, that is the torque unit. Now once that is obtained, you can now simply multiply term by term, which is s cap times something plus y cap times something plus z cap times something. So basically you have to take the cross products like this, right? I do not have to show it again to you. But the final result after doing that, you will get that tau vector is like 0.457 minus 3x cap minus 4.8 y cap plus 2.4 k cap into in kilonewton into meter units. So now what is the magnitude of the torque? Magnitude of torque is then 0.457 root over of 3 square plus 4.8 square plus 2.4 square, which is like 2.81 kilonewton into meter, which is your magnitude of torque. So basically this was asked in the question. So because the question was in 3D, it was a bit difficult. Not difficult, I will not say difficult, but it was a bit confusing to actually note the directions, what is written or what is given. But basically, the magnitude of the torque you are asked about in kilonewton into meter, where the pivotal point was O and the application of tension point was A. So your R vector was OA vector, and the tension was acting down in the direction of this thing on this turnbuckle, where this is along AB, right? So T vector, the tension is along AB vector, and R vector is along OA vector. These are the main things. Then just you have to know the distance or know the vectors OA and what is the vector AB. Get their expressions. AB vector is important to get the unit vector direction for the force or the tension T, and R vector needs the information about the OA vector. Then you take the cross product and then you take the magnitude of that. So you get a torque value of the order of 2.81 kilonewton into meter. So this is the correct range of answer is 2 to 3. So that is what we have here in our answer. So this is also done. Now question number 5 is that if the equal tensions T in the pulley cable are 100 Newton as shown in the figure. So on this pulley, both ends have T equal to 100 Newton. Express in vector notation the force R exerted on the pulley by the two tensions. Then what is the magnitude of R, that you also have to calculate, right? So in this case, you see there are two ends, this end and this end. This is your x direction and this will be your perpendicular y cap direction, right? So on this end, let's say this is your end number A and this is your end number B. So on end number A you have, this is your Tx, this angle is 60 degree and this is your Ty. And on end number B, you only have component along x, so only Tx equal to 100 and there is no Ty because no perpendicular component can be from a already horizontally placed axis, right? So this is Ty is 0. So here your Tx is T cos 60 degree, which is 100 cos 60 degree, and Ty equal to 100 sin 60 degree, right? So basically let's choose a different page. So question number 5 is telling you that, so this is a pulley. This is one end. Oh sorry, I forgot what was the diagram. Yeah. So this is one end of the pulley. This is the center, x and y defined, and the other end. Okay, right. So this is the pulley. This is one end. This is other end. So this is end A This is end B. So this is T, this is T, this is 60 degree, this is T cos 60 degree, and this is T sin 60 degree, and here it is only T and no Y component. So now you have to use the force balance conditions. Because the pulley is at rest, there is no acceleration that is acting anywhere, no additional force is there, so net force has to be 0 since no acceleration, no motion of the whole pulley. So in that case, force balance equation has to be satisfied. Or no, I am sorry, my mistake. So it is asked in the question that what is the net force acting here. So not force balance. So this terminology is not correct. Basically, I mean to say that we have to calculate what are the different components along different force directions. So if this is your, let's say, x component, x direction. So this is the x direction, and this is the y direction. So I have to take out what are the force components along different two direction, x cap and y cap. Then we can get what's the net force acting on the system of pulley. Okay, so if this is the F net vector has two components, Fx, x cap, plus Fy, y cap. So I have to separately identify what is Fx and what is Fy, right? So now this F comes from the tension of the ropes, right? So like for this end number B, you have Fx equal to Fx1 equal to just T equal to 100 Newton. And at the end A, you have Fx2, let's say, equal to T cos 60 degree, which is T cos, and cos 60 degree, I think is cos 60 degree is half, so this is T by 2. So net Fx from both ends A and B is equal to Fx1 plus Fx2, which is T plus T by 2, which is 3T by 2 Newton. This is along x cap. Now, talking about the vertical components. So at end B, there is no vertical component because this is totally along x. So this is Fy1 equal to 0. But at end A, it has a vertical component which is Fy2 is equal to T sin 60 degree, and you know that sin 60 degree is nothing but root over 3 by 2. This multiplies by T. So net Fy from the two ends A and B is equal to Fy1 plus Fy2 is equal to root over 3 by 2 T, right? This is also in Newton, and this is along y cap. Now you have the individual two components, so it is very easy to now calculate the net force. If vector net is equal to Fx x cap plus Fy y cap, which is Fx is 3T by 2 x cap and Fy is root over 3 by 2T y cap. So now this is the net force that is defined in the question as r vector on the pulley. Okay, so this is the net force vector. Now to determine the magnitude, because it has two components along x and y, so the magnitude of this net force vector is the net force acting, magnitude equal to mod of r is equal to root over of 3T by 2 whole square plus root over of 3 by 2 2T whole square, which is like 9T squared by 4 plus 3T squared by 4, which is like 12 t squared by 4. So this is 3. So this is root over 3 to t in Newton. And you know that t value is 100. So 100 times root over 3 Newton, which is like 173 Newton. So your answer will be, let's go back. Yeah, 173 Newton, which is this answer. This is the correct answer. Alright, so we are left with only 3 questions now. 6 and 7 are kind of connected, and 6 and 7 has elaborate descriptions of the problem in the lecture material itself, which you can look up. It is a very nice and elaborate description on how to solve this kind of a rope problem where there is a suspended cable, either massless or with mass. But in this case, in problem number 6, it is mentioned that there is a ignoring the mass of the cable. That means it is a massless suspension cable. So there is a particular equation that is followed for a massless cable that you can check out from the lecture materials, and then based on that you have to calculate what is the tension at mid length and what is the maximum tension for this cable, and then based on the same question, what is the total length of the cable in this figure in question number 6. So I'm not going to solve the entire thing, but I will give you the hints so that you can solve the rest of the calculation by yourself. So question number 6 is about this massless suspended rope, right? So because you see that in the question, first observe one thing, that there is this weight that it is carrying, and it has the weight is basically weight per unit length, unit horizontal length is suspended from it, which is 12 kg per meter. Weight per unit x or horizontal length, and the cable is massless. That makes the problem a bit simpler. Why? Because you will know that you have to choose infinitesimal length elements to solve this kind of a problem, where there are, because the weight is mentioned per unit horizontal length, so at each portion there will be separate contributions. So based on that we have to choose a length element and proceed with the solution. Like for this case, we take a arbitrary length element of that suspension cable, which is this ds length of that cable. This is the arc length of the suspension cable, and the tension on this cable will always be acting in the tangential direction, right? So on this end, lower end the tension is, let's say, T, and the upper end tension is greater, so this is T plus B2. Okay, now divide in or decompose in components. So this is your horizontal axis. This is the horizontal axis. So this angle we choose as theta, and this angle you choose as theta plus d theta, right? So if this is your t, then it will be your t cos theta, and on this direction will be your t sin theta. So this we considered x cap along positive is along right towards the right, and y cap is positive towards the particularly upwards direction. Now if this is your theta plus d theta, then this is your t plus dt cos of theta plus d theta, and vertically up will be t plus dt sin of theta plus d theta. So now this length element has dx as the infinitesimal x distance and dy is the infinitesimal vertical distance dy. So basically ds is the cable's arc length, or small part of the cable, infinitesimal part of the cable is chosen. Dx and dy are infinitesimal elements along x and y. So what are we doing is basically we divide the entire cable in such smallest infinitesimal elements and treat it like a separate specific problem and then integrate as a whole to get the whole thing. Whole length at the end. So that is our easiest way to solve these kind of problems. Okay, so dx and dy are the infinitesimal length and ds will be clearly root over of dx square plus dy, right? Now there have to be some force balance maintained because the suspension cable is holding the horizontal weight in a very stable equilibrium condition. There is no other force that is acting. So the force balancing has to be maintained. So there is a vertical, there is a weight that is mentioned, which is W per unit length along x is the weight. So for this case, the weight that is holding up on this case will be W dx because W is the weight per unit x length and dx for dx amount of infinitesimal length, the effective weight that it will be holding down is W dx. So what we are getting from here from force balancing is first of all, there will be also a W dx acting in the downwards direction because this is the gravitational force because of the weight of that thing or object that it is carrying. But force balancing, first you get what are the individual components of the net force acting here. So overall x component force is from here towards the minus x direction is t cos theta and towards the plus x direction is this thing. So plus x is taken as the rightward direction. So this is t plus dt cos of theta plus d theta minus towards the left is t cos theta. So minus sorry. So this is t cos theta. Now if you decompose this to simplify, t plus dt cos of theta plus d theta can be considered as cos of a plus b, and you know that formula is cos a plus b is cos a cos b minus sin a sin b. So here you do cos of theta cos of d theta minus sin theta sin d theta minus again t cos theta. So this is t plus dt, again the whole thing. So you have to multiply the whole thing term by term. So this is t cos theta cos d theta. Now further simplify we can do is that d theta is a very small angle, is very small. So you know for very small angles cos of that angle is nearly equal to 1 and sine of that small angle is nearly equal to the same angle d theta. So here this cos d theta will be 1 and sine d theta will be just d theta. So this is into 1 plus this is dt times cos theta again minus t sin theta d theta minus dt d theta sin theta minus this t cos theta. So you see that this cos theta and this cos theta cancels out. Now again there is another further simplification is dt times d theta is nearly 0 because dt is also very small and d theta is also very small. So their product will be even smaller. So we can take the product approximately to 0. So the whole thing becomes smaller and simpler. This is simply dt cos theta minus t sine theta d theta. You see that this can be expressed as d of t cos theta. Why? Because the first term is dt cos theta and the second term is t. Derivative of cos theta is minus sine theta times d theta. So this is the whole expression of derivative of t cos theta. So we are enter fx. Now you see that there is no force acting in the horizontal direction of the rope. No force, no net force along horizontal direction of the rope. That means net force here is 0 or d of t cos theta equal to 0 or d of tx equal to 0. Tx is nothing but the x component of the tension, or which is t cos theta. So we can say that because it is not changing with position, so t cos theta is equal to constant. Tx equal to t cos theta equal to constant, because then only the derivative will be 0. And we consider that this constant value is known, which is t naught. Okay, so basically the x component of tension is same or uniform along the rope at any position, right? So be it the middle position or be it at the edges, but the x component of the tension will always have the same value, which is t naught. Right, now we have to bother about the balancing of force along the y direction. So along y cap, the net force is sum over y fy. And how that is balanced out? So there are components, vertical components from t and t plus dt with theta and theta plus d theta angles, but there is also this weight, vertical weight, which is weighing down the rope. Okay, so this net weight is also acting in this case, which is w times dx. For this dx element of length, the net weight for dx element of length will be w, which is per unit length, times the dx length, okay, which is acting in the downwards direction. So we can, in this diagram we can see that t plus dt sine theta plus d theta is upwards, only t sine theta is downwards. So sorry, this and these will be in the same direction and this is in the opposing direction. So that is how we balance that net y fy is equal to t plus dt sine theta plus d theta minus t sine theta minus w dx. Now because there is no net acceleration in the vertical direction, so this is overall 0. Now this further you can simplify this, that this is t plus dt. Again sine a plus b is equal to sine a cos b plus cos a sine. So sine theta plus d theta will be sine theta cos d theta plus cos theta sine d theta minus t sine theta minus w dx equal to 0. Now cos d theta is nearly equal to 1 and sine d theta is nearly equal to d theta. So this is t plus dt sine theta plus cos theta d theta minus t sine theta minus w dx equal to 0. Equal to, now you again multiply t sine theta plus t cos theta d theta plus dt sine theta plus dt d theta cos theta minus t sine theta minus w dx equal to 0. So this t sine theta and this t sine theta cancels out. dt times d theta will be 0 because both are very small infinitesimal components. Now this whole thing becomes t cos theta d theta plus dt sine theta equal to w dx. Now on the left hand side you can see this can be represented as t derivative of t sine theta equal to w dx. Why? Because you take the derivative, the first term becomes dt sine theta, and on the derivative of theta will be t cos theta d theta. So this is the whole derivative of t sine theta is equal to w dx. So you are getting this from here. So earlier we call it this earlier force balance, we got d cos theta equal to 0, which is our equation number 1, let's say, and t cos theta is equal to constant equal to t naught. This we call as equation number 2. Similarly, for along y cap, this is equation number 3, d of t sine theta equal to w dx. Okay. This also gives you that d dx of t sine theta, if you take the dx to this side, is equal to w. So in our case, w equal to w naught equal to constant, because this is the weight per unit horizontal length. So does not vary with x. So that is why this is constant. This is independent of x. So this is this, right? So d dx of t sine theta into w naught equal to constant. This is our equation number 4. Alright. Now to get a shape of the rope curve or the cable curve, let's say it is y as a function of x. How to do that? We have to eliminate theta. All these things are mentioned or explained in detail in the lecture series. You can see that, watch that. So eliminate theta, how to do that? So first of all, dy dx is the slope of this infinitesimal element, right? Slope can be taken as tan theta, you know. So if this is your t and this is theta, then this angle will also become theta, and this is your dx, this is your dy, this is your ds, right? Okay, so the slope will be tan theta equal to dy by dx. So tan theta can be like t sine theta by t cos theta, where t and t cancels out and sine theta by cos theta makes it tan theta, right? So t sine theta by t cos theta. Whereas now this is dy by dx. Okay, so you take another second derivative of this d dx of dy dx equal to d dx of t sine theta by t cos theta. Now you know that d of t cos theta equal to 0, so this is a constant. So this can be taken out of the integration. So this is t cos theta d dx of t sine theta, and from here you know equation number 4 that d dx of t sine theta is equal to constant, which is w naught, weight per unit horizontal length. So this is 1 by, and t cos theta we defined as a constant t naught. The x component always remains constant for all horizontal length distances. So this is 1 by t naught into another constant that is from equation 2, and this is from equation 4. Using this equation 4 and equation 2 is this. So you get that this is the overall is equal to constant w naught by t naught. Now this makes d2y by dx2 equal to w naught by t naught. So I think in the question it is mentioned as w, but for my convenience I have chosen the same w as w naught to make sure that it always implies that w naught is a constant, it is independent of x. So now this can be your equation number 5. This is a second order differential equation, you can see. So to solve this you need to have two boundary conditions. to get yx from this, to get yx by solving equation number 5. What is that? So basically boundary conditions are at x equal to 0, y equal to 0. This is condition number 1. And second condition is that at x equal to 0, the slope dy dx equal to 0. This is obvious because at the, so we choose for our convenience, we choose the lowest most point or the midpoint of that suspension as our origin. So this is our origin, 0, 0. This is one pivot point, A, let's say. This is the whole length is SA, basically this length. And so this is HA and this is LA. So for our case, this is taken as symmetry. Okay, so this, they are basically one of mirror image of each other. So this is same SB equal to SA will be here for the end B with respect to the origin. Now this distance will be LB equal to LA because they are symmetric to each other, and this distance will be HB equal to height HA because they are also symmetric to each other. So let's say this is H and this whole length is 300 meter, which is L. So in the question it is given that, so it is LA equal to LB, basically L by 2 because they are exactly symmetric with respect to the origin O. This is your lowest or midpoint. This is the midpoint of the suspension. Also the lowest point. This is chosen as our origin. So HA equal to HB equal to common distance H, which is given I think as 60 meter. Okay, and this whole distance of L I think was given as 300 meter. We can check this later. But for now, to solve this second order differential equation in 5, if you put dy dx, this is simply w naught by t naught dx 0 to so this is this, not there will be no limit actually. So w naught t naught into x plus c. But at x equal to 0, dy dx equal to 0, there is no slope here, basically because this is along this direction, so slope is 0, right? Because if you choose the element here, this has a tangential, this is along the tangential direction, so slope is 0. So 0 equal to 0 plus c, that means this constant is also 0. This makes dy dx equal to w naught by t naught times x. This we can check our equation number 6. If you further want to get what is yx, then yx equal to w naught by t naught x dx, which is like w naught by t naught x squared by 2 plus another constant c1. Now at y equal to 0, x equal to 0, y equal to 0. So 0 equal to 0 plus c1, that makes c1 again 0. So we get final y form is equal to yx equal to w naught x squared by 2t. This is the shape of the parabolic, this is the parabolic equation. This is equation number 7. Parabolic equation for shape of the suspended cable, right? Now once we have this, so this is the master formula for a massless cable itself, suspended and balancing a horizontal weight per horizontal length equal to w naught and T naught is the X component of tension at any point of the cable. Now it was asked in the question, if you remember, that what is the tension at the midpoint. Okay. So if you look at the diagram again, you will see that this is your one half of the rope. So this is your origin, 0, 0. This is also your midpoint. So, and this is the other direction, sorry. The other direction. So here, your at midpoint, the only tension acting on here will be your horizontal force component, which is T naught. Which is T naught. There is no vertical component because T naught is itself along the x cap direction. Okay. So, how to get the value of T naught? So, you know that shape of the formula, this Yx. The Yx is known to you with this curve. Yx equal to W naught x squared by 2 T naught. Now, at x equal to L by 2. So, if this overall distance is L, then this half of this distance is basically your L by 2. And this is your H, right? So, at L by 2, Y will be H, right? So, this is x equal to L by 2 and y equal to H, we plug in and you get H equal to W naught by 2 T naught into L by 2 whole square equal to W naught L square divided by 2 T naught. This is 4, 4 into 2, 8, right? So, from here you get T naught equal to W naught L square by 8H, where W naught is equal to mass per unit length is W naught, which is 12 kg per meter, but because it is weight, you also have to multiply by the gravitational acceleration, which is G. In SI units, you have to put the value, and L square is basically 300, the entire length, divided by 8 into 60. So this is basically 12 into 9.8 into 300 square divided by 8. So if you calculate this, you will get a value of 22.1 kilonewton. So this is your answer 1. That is the tension at midpoint. Now this is also T naught, and throughout the every part of the cable, this is the X component of the tension, and this remains uniform throughout. At the midpoint, there is only this T naught, but at other points, except for the midpoint, there is T naught is present as only the X component of the tension, and Y component is present separately, and that varies with the X. So basically, at all other points, T naught, that is a Tx component, remains constant, but the Ty changes with X, which alters the net tension at different points on that cable. But this is the entire tension acting on the midpoint of the cable. Now it is asked that what's the maximum tension at what part of the cable. So you have to first understand where the maximum tension of the cable acts. So where does the maximum tension of the cable act. So for that you have to know what is Ty, right? Ty is nothing but T sine theta. So earlier you had this equation in, I think, equation number 3, that d of T sine theta is equal to W naught dx, which was from equation number 3 earlier. So that is present here, that d of T sine theta is equal to W dx, where W equal to W naught as I have taken. So then T sine theta is your Ty, y component, W naught dx. Then what is your Ty is basically W naught dx from x equal to 0. Okay, so depending on at what distance you are taking, so this will be like W naught x squared, sorry, W naught times x plus some constant. So now you know that this thing Ty, it is linear to x. So as we increase x, that is move further towards the edge or the pivot point from the lowest midpoint, which is basically our origin, then in that case the Ty will keep on increasing. So maximum Ty will happen at x maximum, which is at the extreme end of the rope, is basically L by 2 from origin or mid. So as upper limit we have to take L by 2, 0 to L by 2 W naught dx is equal to W naught into L by 2, which is like 12 kg, 12 into 9.8 into L is basically 300 divided by 2. So if you take this, your value will be 17.64 kilonewton. This is the y component. So net tension at the extreme end of the cable is equal to maximum tension is equal to root over of Tx square plus Ty square, where Tx is P naught is equal to already obtained 22.1 kilonewton, and Ty we have just obtained as 17.64 kilonewton. So you just take this out and you just calculate, right? And you will get this is 28.3 kilonewton. So this is your second answer. So this question is done. 22.1 and 28.3. So let us check. This is correct. This is T mid and T max. Now also the total length of the cable has to be figured out, and this is answer is given as 329 meters. So I'll give you the hint and you can rest of the calculation you can finish up yourself. The main thing I'll be writing down, that what is the total length of that cable, that is S equal to what? Not the horizontal length but the total arc length of the cable. So you know that for such distance the arc length infinitesimally is taken as ds, and ds equal to root over of dx square plus dy square. So this can also taken out as dx common and written as 1 plus dy by dx whole square. Now dy by dx, you just figured out that dy by dx can be written as where was that? Yeah, w naught into x by t naught. Right, it has an expression. So this is dx root over of 1 plus w naught by t naught to x whole square, right? So for half r, for one half hour of the rope or cable, basically you are taking this part and you are not taking. So this is mirror image of that. So whatever you do for one end, you just multiply by 2 and you will get the other total contribution, right? So that is the advantage. We only have to do for one part integration and then multiply by 2. So this is at x equal to 0 and this is at x equal to L by 2 because this whole thing is L. And this is H. So here, if this is your SA, so SA is what we are calculating about first because this is 0, this is O and this is point A. So this length is, arc length is SA. SA is 0 to is equal to L by 2 DSA or DS whatever is basically dx root over of 1 plus w naught squared by t naught square into x squared 0 to L by 2. Now here there is a series expansion that you can do. So to simplify this, you can keep it like w naught x by t naught whole squared to the power of half is there. So you know for binomial expansion formula is that 1 plus n x to the power n is nearly equal to 1 plus n into x plus n into n minus 1 by 2 factor into x squared plus dot 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 whatever other terms. This works. This we can approximate up to this if x is less than 1. Okay. So if x is less than 1, you can then approximate this binomial series like this. Binomial expansion of this power series. Okay. So in this case your n is equal to half and your x is basically w naught x by t naught. So this is nearly equal to 1 plus half times w naught x by, not this thing but this whole square is basically your x. So you can take it like y because otherwise it will create confusion. Y, let's say. Okay. When your y is much less than. So this is considering this is less than 1, then this is n times y plus half into half minus 1 by 2 factorial. Y squared is w naught x by t whole squared squared. So this is 4 plus all the higher order terms. Now higher order terms are contributing not much, so we can ignore them. And you also have to like from the question you know what is the W. W is 12 times 9.8. This is Newton basically. And so x you have to integrate it over and t naught value is also known. T naught is also we have calculated 22.1 Newton. So you can directly to simplify it, you can directly get the ratio of W naught by T naught, which is like 12 into 9.8 by T naught is 22.1. So this is 12 into 9.8 divided by 22.1. 5.32 is like that. So this whole thing you can, because you know this value, now you can take the constants properly, and there is some power series which is like some times x squared plus some this time x to the power 4 plus total. Now for SA you have to integrate dx from 0 to, you have to put this exponential like power series there and integrate from 0 to L by 2 dx to some power series which is 1 plus some x plus, no sorry this is not x because the first term is here x squared, so this is x squared plus something x to the power 4 plus all the higher terms ignored. So this is some x plus some coefficient times x cube by 3 will be there, plus some coefficients times x cube by 5 will be there, plus dot 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 integrated from 0 to, sorry, this is after the integration I am talking about. So this is the upper limit and lower limit as 0 to L by D. Now once you have solved this, then you know the value of SA in terms of all the known values, which is L and everything, these are known in terms of known values, because x you have to always put L by 2 because 0 is only 0. So then once you know S, the total length is just a mirror image is the other part. So this is 2 times SA. So if you calculate this correctly, I think you will get the value of what they have mentioned in the problem, some to 329 meter. So you can complete this calculation yourself. This is 329 meter. This is the way you have to do it. Now the final one is that a worker is trying to load a crate on a trailer cart. He is using a rope to reduce the force he needs to exert. Suppose the mass of the crate is 50 kg. This is the crate, right? And what horizontal pull P must the worker exert on the force to position the crate exactly over the trailer. The problem illustrates the situation of force balance in real life. Consider it as an exercise to practice free body diagram. So first in the question you have to define your system. So your system is basically this whole system of this rope plus crate pulled by a person. Okay, and identify all the interactions, draw the free body diagram. So you can draw the free body diagram like this. That first of all, this is your point where the rope is there, and this man is pulling it, right? So this is right now in the vertical position, but to pull it towards this, to situate this crate over this car, you have to pull it like towards the person. So then it gets bent, right? So then it is like that. So that the crate is now just on top of the car. So then in the common problem, in the common situation like that, the free body diagram will look like this, right? Where it has a crate hanging like that, and the crate has a weight of 50 times g. 50 is the mass and g is the gravitational acceleration. So that is the weight, right? This is the center of mass. Okay. So if this was the earlier crate position and this was the center of mass, then center of mass to this is 2 meter and this is 4 meter. Now I have to use force balance, right? So first of all, as I have drawn the free body diagram, you have to balance out what are the object, what forces this net object is actually experiencing, right? So first of all, obviously there will be a tension on this rope that is pulling the crate. So one force I have already written down, that is this mg force, downwards direction. And this rope has a tension T towards this fixed point. Now because this man is pulling towards this direction, so this force is P along this towards the person, and this T you can divide it in components. It is theta, so this is T cos theta and this is T sin theta. So the overall interactions in this force are in this free body diagram. So you can simplify it like this, that if this is your fixed point P, sorry 0, O, and if this is your point number A, so from this point the man is actually giving you the pull. So from A, let's say this is your A, this is your O. So from this you have your P. P is the pulling force of that person in the horizontal direction. And this is the tension of the rope is T. And let's say, and instead of that, you define so you have to first choose your point wisely. Initially here, like here, I was drawing the diagram not correctly because, let me draw it again, because the points were not matching. So I have to draw it properly so that this up to this is your 4 meter and this is the point where the man is pulling on the rope. This is point A. So up to this is 4 meter. And below this is the crate. This is the center of mass point of that crate and this is up to this point is 2 meter, right? Right. So if you extend this, so it will be like this. This is your center of mass point. Okay. And on from this point you have the man's pull force P. This is the this is the tension on the rope T, and this angle you define as theta. So if this is theta, then this is your T cos theta, and this is your T sin theta, and this has a weight mg downwards direction. So this is again mg. So force balancing tells you that T cos theta is balanced out by this horizontal component of the pulling force P, and T sin theta is balanced out by the weight vertically downwards mg, right? So if you take the ratio, then T cos theta by T sin theta equal to T by mg is equal to T and T cancels out, and this is cot theta, right? So then P is equal to simply mg cot theta. Now how to get the value of P? So you know m is 50 kgs into g is 9.8, but you do not know theta. So what is theta? So to get theta, you have to use the formula of a triangle. So this is theta angle. Up to this point is 4 meter, right? And what are the other informations? Okay, so this lower part was 2 meter. Now you have to position the crate directly over the trailer. Is there any other axis or distance information? I think okay, just let me see. This is 4 meter length, so even if this comes this, basically this is the rope that is up to this point, and the total length of the rope from here to here where the man is pulling. Okay, so cot theta is cos theta. So this is also 4 meter then, and this is theta. So you have to know what is this angle, this distance. So then if you look here, so it is a trailer car and is the pull. Define all the interactions. So this is the 4 meter and this is the 2 meter, the entire length. Okay, sorry, I missed this information. So that was what I was looking for. That there has to be some other dimension that is given, because otherwise no way we can calculate what is this distance. So okay, this is mentioned already, that this point to the, because to move it exactly to the, on top of the car, the crate has to be moved on top of the car. So then this distance is nothing but your, the shift that you have to make, that is 1 meter. So this is given as 1 meter. So then, sorry, this is just your vertical axis. So this is your 4 meter and this is your 1 meter. So what is cos theta here? Cos theta is 1 by 4. And so this distance is basically 4 square minus 1 square. This is 16 minus 1 is root over of 50. So then cot theta is equal to 1 by root over of 50, which is nearly equal to 0.258. So then you put the value here. This is 50 times 9.8 into 0.258, which is nearly equal to 129.1 Newton. So this is your final answer. Okay, so this is the like what is the force, pulling force that the worker must exert to place the freight directly on top of the trailer. So this is the answer you are looking for. That this is 129.1. So this is in the range of the correct answer. Okay, so we are done with all the problems of this lecture. So if there is any doubt, you can let me know, or we can finish the class here. Okay, so we are done with this class. So let us meet in the next class.